Hey everyone, welcome back. Ready to go deep on something that's literally all around us, but we rarely stop to think about.
Yeah. Yeah.
Today we're taking a deep dive into water in the atmosphere.
Sounds refreshing.
It is. We'll be pulling from an excerpt of Fundamentals of Physical Geography to explore.
Ooh, classic.
I know, right? Like, we're going
Yeah.
back to basics, but trust me,
Yeah.
it gets super interesting when you start to see all the amazing things water does up there.
Absolutely. People
Yeah.
don't realize how dynamic it is.
Right. Like, we all know what humidity is.
Well,
That sticky, muggy feeling. But have you ever thought about, like, the science behind it?
It's more than just a feeling, that's for sure.
Our source talks about this thing called absolute humidity. Does that ring a bell?
Oh, yeah. Absolute humidity. That's just a measure of how much water vapor is actually in the air at a given time.
Okay.
Like literally the amount of water molecules floating around.
So the more there is, the more we feel it, like,
Exactly. The higher the absolute humidity, the more saturated the air feels. It gets harder to breathe because the air is thick
oh,
and sweat doesn't evaporate as easily.
which makes it feel even muggier.
Makes sense, right?
Totally. But then there's also this thing about how sometimes a warm day can be muggy,
Uh-huh.
and sometimes it's warm but dry.
Yeah. Good point.
Is that where relative humidity comes in?
Bingo. Relative humidity is all about percentages.
Okay.
It tells us how much moisture is in the air compared to how much it could hold at that temperature.
So, like, how full the air is?
Exactly. Like if you have a glass of water that's half full,
Right.
that's 50%.
Got it.
So a warm day with high relative humidity means the air is close to its saturation point.
Ah, okay. So even though it's the same temperature,
Yeah.
if the relative humidity is high, it'll feel much stickier.
Exactly. Because the air is already almost full of moisture, your sweat can't evaporate as easily.
Ah, that's the worst.
It's like wearing a wet blanket on a hot day.
And that brings us to the dew point. Oh, yeah, the dew point. I always hear that in weather reports.
It's the temperature where the air would hit 100% relative humidity.
Okay.
Full to the brim.
Yeah.
Any extra moisture has got to go somewhere so it condenses.
So, like those little water droplets on a cold glass?
Exactly. That's condensation in action.
Wow, I never thought of it like
Yeah.
that. So condensation is basically just water vapor in the air turning back into liquid.
Yep. Think of it like nature's tiny water cycle. Heat makes water evaporate into vapor.
During the day.
Right. And as things cool down, usually at night the air can't hold as much moisture.
So some of it turns back into liquid.
And that's how you get dew on grass and stuff. If it's below freezing,
Then you get frost.
yeah, those pretty ice crystals are just frozen condensation.
Wow. So it's basically the same process on a tiny scale as like rain clouds.
It's all connected. Speaking of larger scale, let's not forget fog.
Ooh, yeah, fog.
Spooky.
Right. It's basically a cloud at ground level.
Oh,
It forms when warm, moist air moves over a cooler surface. So it's like the dew point, but happening like over a huge area.
Exactly. Reduces visibility.
It makes everything damp and mysterious.
And sometimes dangerous, too.
Yeah, good point. Speaking of clouds, those massive ones up in the sky.
Ah, clouds. Now, those are fascinating.
They're just kind of there.
You think so? They actually come in a bunch of different types. Remember those basic ones from our textbook?
Oh, gosh.
Cirrus, cumulus, stratus, nimbus.
Vaguely. I always just thought a cloud is a cloud.
Not at all. Each one tells a different story about what's going on in the atmosphere.
Really?
Cirrus clouds, those wispy, feathery ones way up high.
Yeah.
Those are often made of ice crystals,
Whoa.
usually a sign of fair weather, but they can also mean a weather system is coming.
No way.
Then you have cumulus clouds. Those are the puffy cotton ball ones.
All of those.
The classic fair weather cloud. But if they get tall and develop a dark base,
Uh-oh.
that could mean thunderstorms are brewing.
So you're saying I can predict the weather just by looking at the clouds?
To some extent, yeah.
That's awesome. What about those flat gray ones that cover the whole sky?
Those are stratus clouds. They often bring overcast conditions and sometimes even drizzle.
And then there are the really dark and heavy ones that look like they're about to burst.
You're talking about nimbus clouds. The heavy hitters of the cloud world.
Nimbus. That sounds intense.
They are. Those are the ones associated with precipitation.
So rain, snow, all that.
All that. Full of moisture, ready to let loose on the world below.
It's mind-blowing how water vapor can turn into all these different cloud formations.
Yeah, it's pretty incredible. And speaking of letting loose, that brings us to precipitation.
Right. All that condensed water has got to come back down somehow.
It does. Precipitation is just the fancy term for any form of water falling back to Earth.
So whether it's a light sprinkle or a torrential downpour.
Exactly.
I've always been fascinated by the different types of precipitation. We have everything from those tiny raindrops to delicate snowflakes.
It's like nature has this whole arsenal of water weaponry.
It really does, and each type forms in its own unique way, like snow, for example.
Yeah, snowflakes. Those form when water vapor converts directly into ice crystals, skipping the liquid stage altogether.
So they're basically like frozen clouds.
You could say that. And that explains why they're so delicate and intricate.
That's amazing. And then there's sleet, those tiny ice pellets that are kind of a pain.
Sleet, yeah, not quite snow, not quite rain, just icy and slippery.
Definitely the less glamorous form of frozen precipitation.
But hey, at least it's not hail. Hailstorms are a whole different story.
Oh yeah, those can be intense. How do those icy balls even form?
Hail forms within thunderstorms, where powerful updrafts carry raindrops high up into the cloud where it's below freezing.
Oh, so they freeze and then...
They freeze, fall back down a bit, get coated with more water, and then get lifted back up into the freezing zone again.
Wow, so it's like a wild ride for those raindrops.
It is. And this cycle keeps going until the hailstones get too heavy for the updrafts to support, and they fall to the ground. Sometimes they get huge.
Like golf ball size, right? I've seen pictures. So we've got all these ways water can fall from the sky. But is all rain the same? I mean, does it all form in the same way?
That's a great question, and the answer is no. Our source talks about three main types of rainfall: convectional, orographic, and cyclonic.
3 different types of rain. Okay, I'm intrigued. Let's break those down one by one. What's a convectional rain all about?
Convectional rain is your classic summertime downpour. Think those sudden thunderstorms that roll in on a hot afternoon.
Okay, I've definitely experienced those.
Happens when the sun heats the ground, causing warm, moist air to rise rapidly. As that air rises, it cools and condenses, forming those big cumulonimbus clouds we talked about.
Right.
And when those clouds hit their saturation point, boom! Intense, often short-lived showers.
So that's what's happening. It all makes sense now. What about orographic rain? That sounds more complicated.
It's not too bad. Orographic rain happens when moist air is forced to rise over a mountain range.
Oh.
So as the air goes up, it cools, condenses, and dumps rain on one side of the mountain.
And then the other side gets nothing.
Exactly. The leeward side, as it's called, ends up in what we call a rain shadow. That's actually how some deserts form.
Wow. Mountains are like giant rain barriers. That's amazing. Okay, so what about the last type, cyclonic rain?
Cyclonic rain is tied to those low-pressure weather systems.
Also known as cyclones.
Right. These systems draw in moist air from the surrounding areas, cause it to rise and condense, and you get widespread rainfall.
So those are the ones that bring those classic rainy days that seem to last forever.
You got it. Gray skies, steady rainfall. Perfect for curling up with a good book.
I can picture it now. Wow, we've covered a lot of ground here. From those tiny dewdrops to massive hailstorms, it's incredible how dynamic water is in the atmosphere.
It really is. And we've only just scratched the surface. In the next part of our deep dive, we'll zoom out and explore global rainfall patterns, how this vital resource is distributed across our planet.
Can't wait. We'll be right back. Okay, so we're back. We've been digging into humidity, condensation, precipitation, all that good stuff.
All the building blocks?
Exactly. But now I'm kind of curious about the bigger picture, you know?
Zoom me out a bit.
Yeah, like our source fundamentals of physical geography mentions global rainfall patterns.
Right.
And I've always been fascinated by how some parts of the world are like super rainy and others are deserts.
It's pretty amazing, isn't it?
Totally. What causes those differences? Like, why are some places so lush and others bone dry?
Well, it's a whole bunch of factors all playing together. Think of it like a giant puzzle where you've got latitude, proximity to oceans, mountains, wind patterns.
Wow. Okay, there's a lot going on.
Yeah, it's all connected. But let's start with latitude.
Okay.
Our source mentions that rainfall generally decreases as you move from the equator towards the poles.
Yeah, that makes sense. The tropics are like super rainy.
Right. And it all comes down to heat. The tropics get the most direct sunlight.
So it's hotter.
Hotter temperatures lead to more evaporation. All that moisture rising from the oceans basically fuels those intense thunderstorms we were talking about.
Ah, so the tropics are like a giant humidifier.
Pretty much.
Yeah.
Constantly pumping moisture into the atmosphere.
Okay, that makes sense. But then as you move away from the equator...
Yeah. The sun's rays hit the earth at a less direct angle.
So it's colder.
Colder means less evaporation, less moisture in the air.
Which explains why places like the Arctic and Antarctica are so dry.
Exactly. Even though they're covered in ice, it's super dry air.
That's wild. Okay, so latitude plays a big role. What about coastal areas? They seem to get a lot of rain no matter where they are.
Good point. You're right, proximity to oceans is another big factor.
Makes sense. Oceans are huge.
Massive reservoirs of water constantly providing moisture.
So the closer you are to the ocean, the more rain you tend to get.
Generally, yes. Winds carry all that evaporated water inland.
But even coastal areas can have droughts.
True. It's not just about being near water, it's also about how that moisture moves and interacts with the landscape.
Right, right.
Remember orographic rain?
Oh, yeah.
Hmm.
When mountains force the air upwards, creating that rain shadow effect.
Exactly. So you could have a coastal area right next to a mountain range.
Okay.
And the side facing the wind is lush and green.
But the other side is a desert.
Pretty dramatic, right? Mountains are like giant rain barriers,
Yeah.
shaping regional rainfall patterns.
That is amazing. Okay, so we've got latitude, oceans, mountains. What about wind?
Wind is like the invisible hand moving all that moisture around.
Like those big air currents I hear about.
Yeah, like the jet stream. Those massive currents transport evaporated water from the tropics towards the poles.
So wind patterns determine where the rain goes.
To a large extent, yes. For instance, on the west coasts of continents, in the cool temperate zone.
Like here in North America.
Exactly. They often get a lot of rain because of the prevailing westerly winds bringing moisture from the ocean.
Ah, so that explains those lush forests in the Pacific Northwest.
Yep. But on the flip side,
The east coasts are drier.
you got it. Because the winds there are coming from the land, not the ocean.
It's like a giant game of atmospheric tug of war. Some areas win, some lose.
That's a great way to put it. And all these factors together create this incredibly diverse tapestry of rainfall across the globe.
And that's why we have rainforests, deserts, everything in between.
Precisely. Each ecosystem adapted to its particular rainfall regime.
It's also interconnected. But speaking of interconnectedness, how does climate change play into all of this? I mean, it's got to be impacting rainfall patterns, right?
Oh, absolutely. Climate change is like throwing a wrench into this delicate system we've been talking about.
Okay. In what ways?
Well, for one, it's intensifying the hydrological cycle.
The what now?
Sorry, the hydrological cycle. It's basically the continuous movement of water on, above, and below the surface of the Earth.
Oh, right, right.
So as global temperatures rise, you get more evaporation, more moisture in the atmosphere.
Leading to more rain overall.
In some areas, yes.
Hmm.
But it's not just about the total amount, it's also about the intensity. We're seeing more frequent and intense rainfall events.
Like those sudden downpours and flash floods we keep hearing about.
Exactly. Those extreme events can overwhelm drainage systems, cause flooding, erosion, damage infrastructure.
Wow, that sounds serious.
It is. And on the flip side, some regions are actually getting drier.
Wait, so it's more rain in some places and less in others.
That's right. Higher temperatures can speed up evaporation from soils and vegetation,
leading to droughts.
especially in areas that are already prone to drought. It's a double whammy: too much water in some places, not enough in others.
It's like the planet is out of balance.
In a way, yes. And it creates a lot of challenges, especially with growing populations and increasing demands for fresh water.
Right, water is essential for everything, but it's not just about rainfall, is it?
No, it's also about how that rainwater is stored and distributed.
Like groundwater, rivers, lakes, all that.
Exactly. All those things are being affected by climate change, too.
So even if there's enough rain overall,
It might not be in the right place at the right time.
or it might not be stored properly.
Right. We need to be thinking about sustainable water management.
So we can adapt to these changes.
Exactly. We can't rely on the past anymore. Things are shifting.
This is a lot to take in, but it's super important stuff.
It is. Water is fundamental to life, and understanding how these systems work
And how they're changing.
is crucial for the future of our planet.
So we've really gone deep on this journey into the world of water in the atmosphere.
Yeah, from those tiny little molecules to like global rainfall patterns.
It's amazing how much water shapes our planet.
Oh, absolutely.
Yeah.
It's the lifeblood, really, driving weather, sculpting landscapes.
But as we've been talking about, it's a system under pressure.
Yeah, human activities, climate change, it's all having an impact.
You mentioned earlier climate change is like throwing a wrench in the gears. Can you talk more about that? Like specifically how it's messing with global rainfall?
Sure. One of the big things is this intensification of the hydrological cycle.
Okay, yeah, so
It's basically the way water moves around, evaporates, condenses, precipitates.
right, the water cycle.
Exactly. So as temperatures rise, more evaporation happens,
More moisture in the air.
which can lead to more intense rainfall events.
So it's not just that it's rainier overall.
Right. It's more about these sudden downpours, flash floods, those sorts of things.
Like we've been seeing in the news.
Yeah, exactly. And those could be really damaging. Overwhelmed drainage systems cause erosion.
I can imagine.
And then on the other end of the spectrum, you have areas getting drier.
Wait, so it's wetter in some places but drier in others?
Unfortunately, yeah. Warmer temperatures also mean faster evaporation from the ground, from plants.
So droughts are getting worse.
Especially in places that are already dry. It's like a double whammy.
Too much water here, not enough there.
And that obviously creates a lot of problems for people.
Yeah, for everything, really.
Food security, access to clean water, it's a huge issue.
And it's only going to get worse with climate change, right?
Most likely, yeah. Unless we take action to mitigate it.
So what can we do? I mean, this all seems so big and overwhelming.
It can feel that way, but there are things we can do.
Like what?
Well, on a personal level, we can conserve water, reduce our own carbon footprint.
Simple things like taking shorter showers, driving less.
Exactly. Every little bit helps. And then on a larger scale, we need to support policies that address climate change.
Renewable energy, things like that.
Right. We need to transition away from fossil fuels.
It sounds like we need a whole system change.
In a way, yes. We need to rethink our relationship with water.
And with the planet as a whole.
Absolutely. We're all connected, and what we do affects everyone.
There's a lot to think about.
It is. But it's also empowering to know that we can make a difference.
That's true. Well, this has been a fascinating deep dive. I feel like I've learned so much.
Me too. It's always fun to explore these topics.
And water is something we all experience every day.
Right.
Yeah.
From the rain to the clouds to the glass of water we drink.
It's all connected.
And hopefully, now you'll see it in a new light.
I know I will. So to our listeners, next time you see a raindrop or a cloud, take a moment to think about the incredible journey it's been on.
And how it connects us all.
And let's all do our part to make sure this vital cycle keeps going.
Well said. Thanks for joining us on this deep dive.
We'll see you next time.